Hey guys, so today we're going to go ahead and talk about percent error. So the first thing we're going to talk about is its definition. So what is the percent error? Why do we find it? We find percent error in order to tell us how accurate our measurements are. The higher the percent error, the farther off we are away from what's true or accepted. So what is it? Well, it's helps us determine. So it determines if a measurement is accurate. And if you remember from our discussion on our vocab from 2.2, accurate just means being very close to what is accepted. So again, percent error gives us a percentage about how accurate we are with our measurements. So there's going to be two variables that you deal with in percent area. So two factors, or maybe if you're getting word problems, that you are going to have to pull out and tell me what they are. The first variable that you're going to find is basically the experimental variable. The second variable is going to be the true variable. Or we can even call these values experimental value or true value. Okay, so we already did talk about the formula, so this should be a preview from yesterday, or a review from yesterday. So our formula, the way we find our percent error, we take our experimental value, I'm just going to put EX for experimental and then put value, minus our true value, and we divide that by our true value. If I could spell true, there we go, true value. Okay, so then after we find the answer and we actually go through that, we're going to multiply that by 100. And you're going to get your percentage. So let's do this example. So if a student made a mistake when measuring the volume of a big container, he found the volume to be 65 liters. All right, so that's when every time I come across the number, I like to underline it, or every time I come across something that I find important in a word problem, I underline. It's really important. So then, however, the real value of the volume is 50 liters. What is the percent error? Now, in order for you to get points on your homework or any kind of problem like this, you need to tell me what the variables are in that problem. So the first variable we have to deal with is, what was the experimental value? So the experimental value, if you read through it, it's what they found. So what he found to be was 65 liters. Now, notice that I'm also including units here. That's also important because liters is different than grams. They're different measurements for different things, okay? So one is for volume, one is for mass. So make sure you're always including your units. Then we have the real value. Or we called it the true before. So real, let's make sure we just put true in here so you remember. I don't know why I'm not doing that correctly. Okay, so real or true. Don't ask me why I can't spell that today. Okay, so the true value. All right, so that's basically what is accepted. And so it says the real value, it's blatant, tells you is 50 liters. All right, so now we just had to plug things in. So if we look at our equation from up here, we just put in the first one is the experimental value. So I'm going to draw my division line. Well, we said my experimental value is 65 liters minus my true value. We said the true value or the real value was 50 liters. Then the true value at the bottom. So the true value is down then at the bottom, or the real value is 50 liters. Okay, so then we would put the times 100 when we're done with that. So the first thing that we do is what's in the parentheses. So number one, we have to take 65 minus 50, which you should know equals 15 liters. Okay, then we have to take, for step 2, okay, we're going to take 15, and because it's on top, or it would be on top, we're going to divide it by 50. Now, obviously, 50 cannot go into 15, so we're going to make sure we have to add our decimal there. And we're going to add our placeholder zeros after that. So when 50 goes into 15, it can't, so we're going to put our 0. our decimal. It can go into 150 though, and it can go into 150 3 times, and it goes into it perfectly. Okay, so our third step is taking that 0.3 and multiplying it by 100. Now here's a hint. The number of zeros there are tells us the number of times we have to move the decimal. So there's 2 zeros. We have to move the decimal over to the right, because you're multiplying it by a bigger number, twice. So 0.3 times 100 would equal 30, and we are looking for a percentage, so it would be 30%. All right, so there's your example. Your homework is the variable practice, or not variable practice, sorry, your percent error practice. I hope this helped. Rewatch it if you need to, pause it if you need to, and have a nice day.